Hi, and welcome to another edition of our Whiteboard Wednesdays. Today I want to talk about some wireless network myths and fallacies that we run into in the field very often. These are 10 common wireless mistakes that people make when deploying their wireless LANs. And this ranges from anything from the customers that we engage with to other engineers, other system administrators, just not having the RF know-how about Wi-Fi and how it actually works. The first one we run into a lot is that the understanding that automated RF management fixes all issues. This is a false statement. A lot of vendors and manufacturers will sell their product as having this automated RF management system that can take care of all issues. And that's false, that's not true. It all goes back to the design. If you start with a good design and your design is solid, those automated RF management systems or features work really well because they can compensate for that 5 to 10% dynamic shift in the wireless LAN behaviors and performance. But if you're asking that system or that feature to address 20 to 30% change in the network, it's just not going to work. So what you have to do is start with a good solid design, make sure everything is tuned really well, and then those features can work when you have those small dynamic changes in your wireless LAN. The second myth or fallacy that we run into a lot is that more APs is always better. And this is definitely false. A lot of times we'll go into an environment where 2 or 3 access points properly designed and tuned will actually do the job, but we'll see 5 to 10 access points in that environment that are being asked to do the job. And what's happened in the past is that they put a couple access points thinking that was enough to accommodate the capacity and the coverage in that area, and they run into Wi-Fi issues. And because they don't have the insight or the tools to understand what the actual root cause is, they just throw up more access points, hoping that that's going to address the issue. And what it really does is it actually implements more issues for them and induces more challenges on the RF side for the network and causes a myriad of other problems. So more APs is definitely not better. Another myth or fallacy that we run into in the field very often is that the idea that more transmit power on the access points is actually better. I don't know if any of you can reference back to the Spinal Tap documentary where they had 11 as the high level for the volume. A lot of times we'll see access points turned up to 11 or full power, and that's not the way that you design or configure a wireless LAN. The APs have to be tuned to have a symmetrical power with the transmit and receive of the client devices. Whether it's a phone, a tablet, or a laptop, you always want to address the least capable device, which in most instances is that phone. It might be a small milliwatt transmitter, like a 20 to 30 milliwatt transmitter, whereas a laptop may be a 50 to 60 milliwatt transmitter, and then the AP is a 100 milliwatt. If you had the AP at 100 milliwatts, the devices could see it just fine, but at the edge of the cell where the coverage ends, the devices are still seeing that AP transmit very loudly, but they can't transmit back that same distance. So what you have is the devices appear to have a great Wi-Fi connection, but their performance is really slow and it's confusing to them. It's a mystery. And what's happening is the device can't transmit back that same distance, so it's never getting an acknowledgement from the system that it's received its transmission. And so the device just keeps transmitting that same packet, that same information over and over again. And what that does is it ties up airtime for the system and impacts everybody on that wireless LAN. So more transmit power is definitely not better. Another myth or fallacy statement that we see a lot or we run into is that we'll go into to see a customer or potential customer and they're telling us that they don't allow Wi-Fi in their business. This could be for security reasons or cost, or just they don't think that they have a need for Wi-Fi devices. So the statement is false. What happens a lot of times is we'll go into these meetings, they'll tell us that they don't allow Wi-Fi because of security concerns or what have you, and I'll actually have my laptop open in the Wi-Fi scanning, and I'll see other Wi-Fi networks within the facility. I know they're within the facility because the signal level is at a certain level that I know that it's got to be within their 4 walls. And so if you don't have Wi-Fi, you won't know that there's other Wi-Fi there. Now, you could do audits or surveys periodically to see if there's Wi-Fi, but again, that's a snapshot in time, and you don't know if those things are popping up intermittently coming and going, whatever. Or it could be an intrusion attempt from a hacker trying to provide Wi-Fi connectivity into your wired network. So we always recommend, at a minimum, at the base, have some sort of Wi-Fi in your facility just to do Wi-Fi scanning real-time, 24/7, 365. Another myth or fallacy that we run into very often is that surveys only need to be done once. This again is a false statement. Wi-Fi surveys are done for a myriad of reasons. It's either to validate a design that's going to be deployed in that facility. The survey could be done just to provide or prove that there's good coverage, or they could be an active survey actually testing some performance metrics. But that's a snapshot in time. Wireless LANs are dynamic. They change over time, whether it's users migrating from one area to another, new applications, new devices being employed into the environment. And so surveys really can only give you an idea of what the wireless LAN was performing or looked like at that time when the survey was done. And what we recommend is having surveys done periodically over time, using the first one as a benchmark, and then see how your wireless LAN changes over time, whether it's every 6 months, every year, what have you. And then supplement that with some sort of measurement tool or utility that's real-time, 24/7, 365, measuring the performance of your wireless LAN throughout the area, whether you've got a campus or a single building or you're in an office on a single floor, and then correlate those two things. So you've got these snapshots in time, and then correlate them with your real-time metrics that are being measured on a daily basis all the time, and then see how is your wireless LAN changing over time, and is it addressing the needs of what you're trying to do, those devices or those applications, or is it failing? And so those will give you some insight into how you can address the needs of your wireless LAN. This next Wi-Fi myth or fallacy that we run into is a challenge for us, because what happens a lot of times is the manufacturers and the vendors actually enable this by default, and people want to know why we don't recommend that it be run. And what it is the statement that 80 megahertz channels are always faster. This is again false, but it's kind of walks that line of being true and false, and it depends. 80 megahertz can work if you are in an area where you're not surrounded by other Wi-Fi networks, or you don't have any type of Wi-Fi contention or congestion going on. If you're a remote business and you've got no neighbors and there's no RF impacting your environment, 80 megahertz may work well for you if you just got a couple of access points. Up to, I think 3 or 4 would actually work. But if you get anything over 3 or 4 access points and you're in an environment where you've got multiple, whether it's dozens, hundreds, thousands of access points, or you're in an environment where there are other networks surrounding you, whether you're in a mall or a shared office tower, 80 megahertz channels, not only are you going to not be a good RF neighbor, but you're also going to impact the performance for yourself. So in those environments, we only recommend 20 megahertz. That gives you the most channels to choose from, reduces your co-channel and your adjacent channel contention, and will just improve the overall performance of your network. So 80 megahertz channels are not always faster. So this next myth fallacy statement that we love is that it's always the wireless that's at fault. This is false. I've been doing this for a long time, and we get the calls and the tickets, and we'll drill in to look at what the issue is with the Wi-Fi, and we find out it's really not the Wi-Fi that's at fault, it's something else. So there's a myriad of things that can impact Wi-Fi performance. Could be anything from back-end network services like DHCP and DNS, network congestion, even things like authentication. So if the authentication server is down or it's not replying quickly enough, lag time, response times go up, devices may time out. There's a myriad of problems that affect how Wi-Fi performs. So what we always recommend is having some sort of tool or utility that can monitor your Wi-Fi and your network over time and correlate the two. So it'll help you get to a root cause of what your Wi-Fi issue is, whether it's a wired network issue, a back-end network services issue, or if it's truly an RF issue, something that has to do with, spectrum contention or channel contention or just overall RF performance. We recommend some sort of tool or utility or solution that can measure that and give you root cause so you can resolve the issue quickly. Another myth or fallacy that we run into and have to explain a lot is that the Wi-Fi system controls the client device behavior. This is false. In the cellular world, when you're traveling down the road with your cell phone and you're on the interstate, the cell towers actually tell your phone when to disconnect from one tower and connect to the next closest tower. In the Wi-Fi world, I wish it worked that way, but it wasn't written that way in the outset. The way the Wi-Fi works is that the onus was put on the client devices to make the decision on when to disconnect from an access point and reconnect to another. Now, historically, the devices don't make the best decisions on how to do that. That can be improved by making sure that patches and updates to the operating system are done and that client drivers for the wireless NIC are updated into the most recent stable, best behaving version of the driver. Sometimes you can reference the vendor websites and they'll tell you which ones have been tested and which versions are most interoperable and what they recommend. But typically just having them up to date will improve the Wi-Fi system performance for those client devices. So there are some things that you can do on the design side, and we always address this by looking at the applications and the types of devices that we're going to be using on the wireless LAN. And then we design the wireless LAN to accommodate those devices the best way possible. And we're always looking at the least capable device, whether it's a phone or some sort of low power device. And we're tuning the network to make sure that those devices are accommodated so they can roam from one access point to another and it's seamless. And if we know that we're tuning for something like a voice over IP application or even a video application, we are addressing that with different types of quality of service or prioritization through the air and through on the wire to make sure that performance works really well for those devices so that the Wi-Fi doesn't get blamed for making improper decisions. The next myth or fallacy that we run into a lot is that one-for-one replacement of your legacy wireless LAN is acceptable. Again, this depends, but in most instances this is false. In the old 802.11abg legacy Wi-Fi days, when we moved from the legacy solution of the technology to 802.11n, we learned some lessons in that one-for-one replacement of the access points in the wireless LAN was not a good method for design. There were several things that were happening about that same time that caused us to rethink our design schema and our methodology about how we design wireless LANs back then. The first thing that changed was that we went from the ABG diversity antenna on the access points to the MIMO antennas in technology on the 802.11 access points. And this did a couple of things. It increased channel contention, whether it's adjacent or co-channel contention. We also saw the introduction of really low power devices like iPads, iPhones, which had a fractional power capability of like laptops, which were traditionally the things that we designed for before. And so we had to rethink how we were actually doing our design methodology. And what we found is that the access points had to move closer to the clients, the devices. So this meant we had to shift the APs out of the hallways into the rooms, whether it was a hotel room, a hospital room, a dorm room, a classroom. We had to put more access points in an auditorium to do coverage and cover capacity concerns. So just taking the existing AP locations and replacing with new APs is not a good methodology. Even today, when we move from N deployments to AC, we're still going back and revisiting to make sure that we're doing proper coverage for 5 gigahertz because the majority of the devices are migrated to that spectrum or that band, which has the most channels and the most bandwidth and will perform the best. And we want to make sure link symmetry is there, and so we're designing for that. So again, one-for-one replacement of your legacy wireless LAN is really not acceptable. You should always go back and address and look at the design and make sure that the current technology fits into that plan, and if it doesn't, then you've got to make some changes on the design side. So as a solutions provider and an engineering firm, we run into this next myth and fallacy quite often, and it's the statement that Wi-Fi is the source of all my headaches, and this is definitely false. What we find a lot of times is the Wi-Fi devices that are more likely to blame. These are the tablets, the phones, the laptops. They all use different chipsets. The chipsets have different driver versions. Those drivers are written by different people to behave in different ways. We've even seen, two same devices, same driver, sitting right next to each other, stationary on a desktop, perform completely different. One will stay connected, the other one will flip back and forth between two access points. And so we know it's the devices that are to blame. Not to say that they're always to blame, but they're definitely part of it, right? My mom used to say it takes two to tango. So you have to look at the devices, you have to look at the Wi-Fi, you have to look at the network and the network services as to what could be the root cause. And again, we always recommend some sort of tool, solution, or utility that can monitor and test the performance of your network over time to help you drill down and understand what's at root cause for any performance issues that are degrading my network. If you have more questions, you can make comments down below and we will respond to those. And I hope you guys join us for our next Whiteboard Wednesday.